Hello, and welcome to the third week of the course. My name is Marina Peter. I work for the University of Applied Sciences, Northwestern Switzerland, Institute of Entrepreneurship. I'm a research scientist and an engineer working in the field of drinking water supply and treatment in the low-income country context. This week, we will focus on the drinking water supply systems and technologies. Also, the major focus is on the engineering aspects. We should keep in mind that management, organization, regulatory aspects, as well as user perception and participation, are as important as proper planning and engineering. Let's have a look at the learning objectives of the week 3 of the course. Those are: to learn the 6 functional groups of a water supply system, understand which technologies belong to which functional group, understand basic principles and functionality of each technology, and finally, in order to be able to define strategy and emergency response, we will discuss immediate and long-term actions for the development or rehabilitation of a water supply system in an emergency context. What is a water supply system? Let's see. There is a pure spring in the mountains. We protect it and deliver water by gravity to the village nearby, where it can be collected at the standpipe. Or we build an intake on the river down in the valley. Pump water up to the drinking water treatment plant. Treated water is pumped further and stored at the tank, from where it is further distributed to the town through a distribution system. In the village further down the valley, people collect water at the protected well with a hand pump. They carry water in jerrycans home. A local NGO has distributed the household filters to treat water at home in the village next to the river. Few households also collect rainwater from their roofs and store it in rainwater tanks. All these different types of water supply systems have different scale. However, they have all the same steps: water source, spring, well, surface or groundwater, water intake structure, be it either a protected river intake, spring catchment, dark well, or a rainwater gutter. Abstraction technology, such as a hand pump or a motorized pump. Water treatment, if it is required. Water transport, either through a network or with jerrycans. And water storage, such as in rainwater tanks or water treatment at household level. Most water supply systems can be structured along the 6 functional groups: source, intake, abstraction, treatment, distribution and transport, and user safety. The technologies from each functional group perform specific tasks of the water supply system and can be linked between each other to show possible combinations. It is not always necessary that water passes through all functional groups to reach the consumer. In some systems, treatment is excluded due to high quality of source water or water supply by gravity and no pumping is needed. However, water always moves from left to the right through the functional groups or from top down within the group. Here you see an example for a centralized or semi-centralized system supplying and treating surface water. Surface water is collected at a protected or unprotected river or lake intake, is delivered with means of gravity or motorized pumping to the treatment plant. There it is clarified and disinfected and either is being sold at the water kiosk or fed into the distribution network. Safe water storage at home might be needed to cover for interruptions. For a decentralized water supply system, including use of high-quality groundwater, the system will be simpler, excluding treatment step. In some cases, household water treatment might be included to reduce health risks due to recontamination of water during transport. What you have seen on this and past slides are the system templates. This kind of system templates can be developed for different settings. In general, we define 9 major different system templates: rainwater harvesting, surface water treatment, centralized and decentralized, all fresh water sources which are manually transported with household water treatment afterwards, gravity water supplies, high-quality groundwater, groundwater with geogenic contamination, water polluted by anthropogenic contamination, and desalination. These different system templates, as well as information sheets to each technology, are summarized in the Compendium of Drinking Water Systems and Technologies from source to consumer. The technologies presented in the compendium and links between them are not exhaustive. Planners and designers should try to make the best use of available resources, optimize or rehabilitate existing infrastructure while taking into account local enabling environment, including local capacities and skills, financial resources, regulations, and socio-cultural preferences and acceptance. The following steps can be used to pre-select potential water supply options. Identify water sources which are available and accessible. Identify system templates which include and address these water sources. For each template, select a technology from each functional group out of boxes with multiple technologies. In the functional group treatment, multiple technologies depending on potential contamination of water source needed to be selected. The series, following the arrows of technologies, make up a system. Compare different systems and iteratively change individual technologies or use different system templates based on priorities of the users or community, scale, environment, and resources available. In an emergency, we can apply the same functional groups, considering that not all technologies would be appropriate. However, use of available resources, infrastructure, and skills gains even more importance. It can be important to consider immediate, simple, basic measures to improve current poor water supply system first, before planning for a more sophisticated, long-lasting infrastructure. Protecting the source is one of the possible measures. Relocating defecation of ocean areas, as well as animal access downhill, can have a strong immediate impact on water quality as well. Fencing, rail wall, runoff trenches around springs, as well as walls and better access pathways to open wells are another examples of immediate improvement measures. After protecting the source, we have to think along the water supply chain and try to organize missing or non-functional infrastructure, such as pumps and storage tanks. Control distribution, as well as making containers for storing water available, belongs also to the immediate measures. When water is likely to be polluted, chlorination of water at the storage tank on tankers, dosing chlorine to water collection containers, or disinfecting water directly at the well might be the only feasible way to prevent disease outbreaks. When basic measures are in place, further upgrading of the system can be required. Here we have to think beyond the water source only. A properly designed water supply and distribution system is often the next step, and planning is early enough helps to avoid unnecessary efforts and expenditures for maintaining temporary built, possibly fragile and unreliable infrastructure. In case we are talking about displaced population, we should consider the needs and situation of the local communities and possibly upgrade the services for them as well. As any water supply system, adequate source or multiple sources with proper intake structures, adequate storage capacity for uninterrupted water supply, as well as efficient distribution are the main components of the system. In this lecture, we have looked at different water supply systems as a combination of technologies from 6 functional groups. Basically, any water supply system can be pictured so, independently on its scale. However, flexibility is always required. Adapt your system to local needs, geography, availability of skills and resources, as well as preferences and needs. Never one size fits all. Simple and fast measures to improve current systems before designing and installing more sophisticated water supply should always be considered on a short term. On a longer term, progressive improvement of the supply system as well as safeguarding it against contamination are further crucial steps. During the next lectures, we will move through all functional groups with more or less detail and discuss technologies of each group. Till soon!